All right, today we're looking at derivatives and the power rule. We looked at the definition of derivative yesterday. That is a very important procedure, but we don't want to have to be doing that every time we're doing a derivative. So we have some of these rules that will help us out. We're going to start with our general rules here. The 4 basic derivative rules. The first one, the derivative of a constant. That's what this is referencing. C is a constant here. So the derivative of a constant by itself is equal to 0. That should make sense. A constant is the representation of a horizontal line. The slope of a horizontal line is 0. All right, and remember, derivative is just the slope at a point. Number 2 is the power rule. This is the important one. Power rule. Okay, this is saying that if you have the derivative of x to a power, we pull that power down to the front, and we subtract 1 from the power. So x to the 8th will be 8x to the 7th. X to the 100th would be 100x to the 99th. The next one involves multiplying a constant by a function. The derivative of a constant times a function is the same as saying a constant times the derivative of the function. So constants can be pulled out as a multiplier when we're doing derivatives. We're not taking the derivative of each individually, we're pulling out the constant and taking the derivative of the function. And lastly is you have the derivative of 2 things added together. That's the same as doing the derivative of one added and the derivative of another. Notice we don't have a rule here for the derivative of 2 things multiplied together because that's going to be the next lesson on product and quotient rule. All right, so let's look at some practice for these. Each of these you can try and do on your own, but I'm going to go through it and work them so you can pause the video if you want. This first one, we have the y equals x to the 8th. We're going to use our derivative notation to say dy over dx is equal to, and this is just a simple power rule. Pull down the 8th, x to the 7th. And that's our derivative. Number 2 is a constant, same thing. Use our notation, dy over dx. Derivative of 5, which is a constant, is going to be 0. Number 3, this one's a little weird because you're like, well, we haven't talked about square roots. Well, remember, square root of x is the same thing as saying x to the 1/2 power. So we can do the derivative, pull down the 1/2, so 1/2 x to the, and then subtract 1 from the exponent. 1/2 minus 1 is negative 1/2. So we end up with 1 over 2, and then square root of x on the bottom. There's our derivative. And then for number 4, we have 1 over x cubed. Remember, an x to the exponent on the bottom is the same thing as saying it's to a negative exponent. So this is x to the negative 3. So our derivative is negative 3x. And then this is where a lot of people mess up, remembering what we have to do with the exponent. Remember, it's the exponent minus 1. Negative 3 minus 1 is actually negative 4. So we end up with negative 3 over x to the 4th there. Okay, got a few more practice here, and these cover some of the other rules. Let's look at number 5. You can pause and try it yourself if you want. So remember, we had the rule that if we have a constant times a function, our derivative is going to be the constant, which is 8, times the derivative of the function, so 6x to the 5th. So we end up with 48x to the 5th. Similar thing here with the exponent in the last one, the last page. We can rewrite this as 4x to the negative 1/2. So y equals negative 2x to the negative 3/2. Because we're subtracting 1 from the exponent, and we pull down the 1/2 and multiply it by 4. So we end up with negative 2 over x to the 3/2. This one talks about number 7 talks about the addition property we had, which is the derivative of the whole thing added together is the same as the derivative of each individual part added together. So this is going to be 21x squared minus 4, because this is x to the 1, pull down a 1 and subtract it, so it's technically x to the 0, but we don't have to write x to the 0 because that's just equal to 1. And then derivative of a constant here at the end is just going to be 0, so plus 0, but once again, don't need to write it because we don't need to write redundant statements. All right, so there's our derivative. All right, for number 8, we're looking at an exponent here. This is just reminding you how exponents for roots and radicals work, this is 6x to the 1/3. The 1 is the power on the inside, the cubed is the power of the root. All right, so we have f prime of x equals 2, because we pull down the 1/3 and multiply, x to the negative, what is that, 2/3, because we're subtracting 1 from that. So 2 over x to the 2/3. Okay? All right. We can also find the equation of the tangent line this way. Same rules apply. We need x, we need y, and we need slope. Our y we get by just plugging in 2. So f of 2 is going to be 3 times 4, which is 12, minus 2 is 10. And then our slope we can find by finding the derivative. So f prime of x is equal to 6x minus 1. We want the slope at x equals 2. So f prime of 2 is equal to 12 minus 1, which is 11. And so we have xy slope, y minus 10 equals 11 times x minus 2. One thing to note about the derivative, you have to wait to plug in your x value till after you take the derivative. I've seen people try and plug in 2 and take the derivative at the same time. That doesn't work. You have to take the derivative first, and then you can plug in your x value. All right? I'm not going to do another one of these. This is one very similar to the one we just did. Just have to make sure you're doing your derivative properly. I think this is the last thing we're going to look at is the derivative of sine and cosine. If you were in class, I'd get you to graph both of these and think about what the slopes are doing. So I'll draw a model just to see. If we look at this, sine starts at 1, goes to 0, negative 1, 0, 1, 0, and follows that pattern along, or sorry, not sine, that's cosine. Whoops. Sorry, guys. Sine starts at 0 and then goes to 1, 0, 1, 0, all the way, or negative 1, 0, constantly going back and forth. Now, we're trying to take an approximation of the slopes here. Well, this almost looks like a slope of 1. So let's create a graph of the slope. Okay, so we're starting at a value of 1, then this is a slope of 0. This looks like, if I was graphing on the calculator, you'd be able to see it better. It looks like it might be a slope of negative 1 or somewhere down there. This is back to 0. This is back to a positive 1 or maybe something like that. And if we look, this is just the graph of cosine. That's because the derivative of sine is equal to cosine. Now, if we tried to do the same thing with cosine, so here's our graph of cosine. All right, we have graphing the derivative. We have a slope of 0, so starting at 0. But then our next slope is a negative slope. Now, it almost looks like negative 1. So negative 1 down here, 0, positive 1, 0. And so this almost looks like the sine graph, but it's different. Instead of starting by going up, it goes down. So that means that derivative of cosine is equal to negative sine of x. So derivative of cosine is negative sine. All right, that's it for today. You have a worksheet to work on. If you have any questions, please let me know.